So we're fixing to start 5.1 using fundamental trig identities. So I asked you and gave you about 5 to 7 minutes to copy down the trig identities. You should know those by now. Were you familiar with them when you copied them down? Everybody good with that? Okay, so the first example that we're going to do, you should already know how to do.
Oh no.
There are some going to be there are some going to be on the test like this. There are there's some like this on the test. Sorry, I think I just lacked some oxygen. So there's going to be some like these on the test, okay? So, but you should already know how to do these. So these on the test would be like a gift, a present, okay? All right, so but we're going to practice them just to make sure. So example 1. What if I tell you that the secant of u, just some angle, is -3 halves, and the tangent of u is greater than, that little mark's not supposed to be there. The tangent of u is greater than 0. Find all trig functions.
Oh God.
Okay, find all trig functions. So this is what it's going to look like on your test. Okay, it's going to say the sine of u is equal to what? The cosine of u is going to equal to what? The tangent of u is going to equal to what? The cotangent of u will equal to what? The secant of u is equal to what? And the cosecant of u is equal to what? Okay, so now tell me what I know.
Secant.
Yeah, secant of u is equal to -3 halves. That they gave me that one. So what else do I know?
Cosine,
What is it?
-2/3.
Very good. People, if you missed that one, shame on you. All right, -2/3. Okay, so I gotta find all the other ones. Now, what is this talking about? I mean, I understand why they told me this, because given two sides of a triangle, can I find the third side? Yes. So why did they tell me this?
It means
It's
that
positive.
your opposite and adjacent are both going to be negative.
Or positive.
Well, no, because we know one of them's negative.
Yeah.
So they're both going to
So-
be negative.
What?
So they're both going to be negative. If tangent's positive, when we know
Oh, okay.
one's
Okay, so what I'm trying to get is that when I talk about secant being negative, my brain is really thinking cosine, right?
Yes.
So what two quadrants is cosine negative in?
Second and third.
2 and 3.
Yes, the second and third. All students take calculus. All are positive, sine and cosecant are positive, tangent and cotangent are positive, cosine and secant are positive. Okay, so the only place that secant is the reciprocal of cosine is negative are these two, second and third. So if I didn't tell you this, you wouldn't know exactly where to put it, would you? But since I said that tangent is positive, which one of these quadrants, second and third, is tangent positive in?
third.
So the very first thing that I want to do is I want to figure out, where am I? Okay, where am I? So y'all figured out we're in quadrant 3. So now I'm going to draw a picture. Are you with me? Yes?
Yes, yes.
Okay, so I'm in quadrant 3. Here's my triangle, and this is U. Okay? I'm not going to do secant. I don't do secant, but I can do cosine. Okay? Cosine is, look, we're going to find them all, so we could go, oh, heck, a hill of ants. Okay? So cosine is adjacent over hypotenuse. So this is adjacent, it's -2, and my hypotenuse is 3. Remember that hypotenuse, that's the same as a radius. Remember, this is like the XYR worksheet, is what it is. Okay? And they're never negative. Only the sides x's and y's, opposite and adjacent, can be negative. Okay, so I got to find this side over here. So I'm going to use the Pythagorean theorem. So I'm going to say -2 squared if you're, I don't know why you would be, but if you were having to use a calculator, okay, remember to put a negative number in a parentheses before you square it. Plus, I don't know what that is, so I'll call it x squared, equals r squared, 3 squared. A squared plus b squared equals c squared. That's another way to do it. So what's negative 2 squared?
4.
Plus x squared is equal to, 3 squared is?
9.
Subtract the 4 from both sides, and x squared is equal to 5, so what's x?
Square root of 5.
Plus
The
or
square root of 5. Now, it's going down, guys. I'm in the third quadrant. What is it?
Negative.
Negative. Okay? Watch what else I'm going to do. If I'm in the third quadrant, who is the only people, the only functions that are positive? Tangent and cotangent. Everybody else is negative.
You put a negative sign on cotangent.
Thank you. I gotta go shut the doors. I'll let you think about it. Okay, so that's just a double check. Do you understand what I'm saying? This is simply a double check for me. Y'all listen to me. If you see one negative, you know there are
2. Another. More than one.
4.
4.
Uh-oh.
Okay? If you see one negative, there are 4 negatives. All right? So, sine, opposite over hypotenuse. What's the sine of u? Negative square root of 5 over 3. And it's negative like it's supposed to be. Tangent, opposite over adjacent. Negative square root of 5 over negative 2, which is what?
Square root of 5 over 2.
Yeah, positive square root of 5 over 2. Flip it, tell me what you get.
2 over square root of
Flip the top.
5. 3 over square root of 5.
Negative.
Now, do you know how to do this?
Yes.
Yes? Do you remember this? Bring back some memories?
Not really, but I'm trying.
Okay, so I'm just gonna tell you, you might wanna start it. Why?
On test.
It is on your test. Looks just like it. We're not gonna talk about it anymore before the test. I'll go back and remind you and tell you some problems in the book that would be wise to do. Okay, I would save them for the night before the test. Okay, so, because you have this example that you can go by. All right, so now we're really getting into, so here's what's gonna happen. All right, I'm gonna start teaching the lesson today. This stuff is a little bit strange, okay? I cannot work, it's kind of like, I mean, it's not really, but I guess I could equate it to reading problems in that I could stand up here all day and do reading problems. Could I work one of every kind you'll always see?
No.
No, not going to. You just gotta use your head, okay? So I could stand up here and work problems all the time. You're not gonna get any better at it, okay? So here's what's gonna happen. I'm gonna show you some problems today. I'm gonna teach you some strategies. I'm gonna have you write them down of how to work problems. And then I'm gonna show you some stuff. I don't get quite as far as I'd like to get, but I'm gonna give you a worksheet. And here's the way it works. Your first worksheet is 10 problems, and they're all easy except for maybe one of them. One of them's gonna be a little trying, okay? I'm not grading it. You cannot get the paper that's for a grade until you've done the easy worksheet. 10 easy problems, kind of just to reassure yourself and go, okay, and learn a few little tricks, all right? Once you finish that, you turn it into me, and I will give you the worksheet that has 30 problems on it. It's the more difficult worksheet, okay? The way it's graded is this. You get a certain percentage if you worked all the problems. And then I don't remember if I picked 5 or I picked 7. I'm gonna say I picked 5 problems, and I grade those 5 problems. You don't know what 5 they are, okay? So when you skip one, you risk getting docked twice for it. Once because you don't have all of the problems there, and second, if that happened to be one that I graded. Do you understand? So you can't skip any. You'll have tomorrow, Monday, Tuesday, Wednesday. Your test is Thursday, Friday. If we go to the playoffs and we get out early Friday, we will bump that test up. And we will test Wednesday, Thursday. Because here's the way these problems are gonna work on the test. On the first day, I'll give you some problems like this and some other little kind of easier problems, all right? And then I will give you 8 easy identity problems, okay? I'll say pick any 5. Because even though they're easy, sometimes they might have something that you might not. It just might not click with you. You know how that does sometimes? You're doing a reading problem and it's not really hard, but it just like you didn't read it right or something. It just didn't click. So I'm giving you 8 and you have to pick any 5 and work them, okay? The second day, I don't remember if I give you 6. I think I give you 6 and I tell you to pick 3 hard ones. Okay? If you can't work any hard ones, I think the highest grade you can make on the test is an 82. Okay? And before you go home for Thanksgiving, I'll give you the Greek alphabet, and then when we come back after about a week or so, then we'll have a Greek alphabet test. It's a 100-point test. So that's your gimme grade, that's your gimme test. We've had one every 6 weeks. Okay? We did memory tests the first 6 weeks. We did projects last 6 weeks. And this one is the Greek alphabet. You have to memorize 35 symbols.
Oh, God.
Okay? 35 symbols on the Greek alphabet. So a lot of them you'll see on the worksheet, so that'll help. Some you'll be like, what's that? And you'll see them so that you'll be accustomed to some of them. Some of them, if you have older brothers and sisters and they went to college and joined a fraternity or a sorority, then you probably saw them there, okay? Because that's the Greek world. That's where they use all that math. All right, so here we go. Strategies. The first thing we want to do are strategies. Now, these are just things to think about when I'm working these problems, okay? Just things to think about when I'm working these problems. Am I going to use all of them? No. On one problem, you might use 1 or 2, okay? So, but there's some things that we can do. The very first thing is you will work on the most complicated side. So I'm going to look at which side's the messiest, and that's the side I'm going to work on. All right? Number 2, this is a strategy that I might use if my problem's really easy. It's an awesome strategy. If my problem is really difficult, it could make your problem huge and messy. Okay, so it might not be the first thing I apply. But if I tried everything else and I can't get anything that works, then sometimes this is what we resort to. Okay? Put everything in terms of sine and cosine. Okay? Put everything in terms of sine and cosine. For instance, if you had a cosecant, I could write it as 1 over sine. If you had a secant, I could write it as 1 over cosine. If you had a tangent, I could write it as sine over cosine. You see what I'm saying? Okay, so that's something. The next one, if there are 2 fractions put them together. Now, what do you have to put fractions together? Common denominator. Okay, so we'll be looking at that. Number 4, if there is 1 fraction, what might we do to it?
Flip it.
No. Try and take it apart. Write it as 2 fractions, okay? So before we go on, I want to show you what this looks like, okay? So all this is just an example of what I'm talking about right here, okay? Because this one right here lends itself to some crazy junk you people do, okay? So some crazy misconceptions. We want to fix those. So here's what I'm talking about. Let's say that I had x minus 3 over 4. Obviously, it's not going to look like this, people, because you're going to have sines and cosines and stuff like that, all right? But if it did look something like this, okay, can I take this apart?
Yes.
Yes. Is it the same thing as x over 4 minus 3 over 4? That is the same thing, isn't it? Okay? Here's where the mistake comes in. What if I have 5 over x plus 2?
It's X
Is
plus
that
2.
the same thing as 5 over x plus 5 over 2? No, it is not. Okay? So what do I need to remember when I use this one right here? You cannot what?
Change the
Separate the denominators. You cannot separate denominators. All right, you cannot separate denominators. All right, here's another one. Let me look. 6, 7, 8, okay. Another one is if you see something squared or a 1, what's going through my mind? What identity? Yeah, that's a Pythagorean identity. Okay, that's the Pythagorean identity. Something squared. Sine squared plus cosine squared equals 1. 1 plus tan squared equals secant squared. 1 plus cotan squared equals cosecant squared. Okay, Pythagorean identities. So if I see something squared and I see a 1, I'm going to go, oh, this might be a Pythagorean identity. Okay, here's the next one. The next one is you might have to factor. Okay, you might have to factor. Here's one that a lot of kids love. I never ever thought about using this one, okay, until, I don't know, the kids one year, they just went crazy using this, and I was like, what? Never really thought about it, but it was very helpful for them, and they liked it, okay? So, cross multiplying. Okay? Now, you can only cross multiply across a what? An equal sign. You can only cross multiply across an equal sign, okay? And you must have one term on each side of the equal sign. You can't have multiple terms on one side, okay? And you can't cross multiply across a plus sign or, I don't know, all the crazy junk y'all do, okay? Here's the last one. This one is going to be a little bit confusing because we didn't add this one until later, but I'm going to go ahead and write it down now so we don't have to come back and do it. Sometimes you can multiply by a conjugate. Okay, multiply by a conjugate. So this word's going to come back up in a little bit. All right. So are you ready? Okay. So the first, you might want to keep this handy, and you might want to keep your your identities handy. Do you understand? Because those are the things that we're going to be using. All right. So here we go. Example 2. Now I don't much like the way that they start off doing these problems, but I do it. I'm doing it. Okay, but I really would just prefer if they would just give me the regular kind of problems and let us practice on them. But they're going to start off some crazy stuff, so we're going to do it. This one is going to say simplify. Sometimes these are more difficult than what we're working towards, because when we're working towards something, they're going to give you the answer, and you have to figure out how to get it. Okay? So this one's just going to say simplify. So here's what it looks like. Sin x times cosine squared x minus sine x. And they just want me to simplify this and make it look nicer. Okay? So let's try some of those skills. Let's see. Work on the most complicated side. Well, there's only one side, so we don't have to worry about that. Put everything in terms of sine and cosine. Well, guess what, people? It's already in terms of sine and cosine, so we haven't gotten anywhere. Do you see any fractions?
No.
All right, so that's 3 and 4. Do I see something square?
Yes.
Okay, so I'm thinking this might be an identity, but I don't see a sine squared, so that's not working. Can I combine these two terms?
No.
These are not like terms, people. Sine, cosine squared. You can't add that to a side. All right, that's like an xy squared and an x. They can't go together. All right. Okay, so I'll skip. What about this one? Factor.
Yes.
I can factor this, can't I?
Yes.
I got two terms. What do they have in common?
Sine.
Sine. So let's take it out. What do you multiply sine by to get sine cosine squared?
Cosine squared.
All right. What do you multiply sine by to get negative sine?
Negative.
Okay. So now I'm here. Oh.
Now you have a 1.
Do you see? Yeah. Do you see? You think this might be a Pythagorean identity?
Yeah, because I have a
Okay,
square.
so watch, I'm gonna tell you something, okay? So watch this, because they're not gonna just blatantly post a Pythagorean identity out there, all right? So what is the Pythagorean identity that has a cosine squared and a 1? What is the one that you memorized?
Sine squared plus cosine.
Yeah, sine squared plus cosine squared equals 1. That's what you memorized. So can I make this guy look like this guy? That's what we're attempting to do, okay? So I got a cosine squared, and then it's a minus 1. So I'm gonna have to bring this 1 over here. Do you agree with me? And then he becomes a negative 1. So what do I have to take over here?
Sine.
And when you bring him over here, what does he become?
Negative.
Negative sine squared. So this right here is equal to what? Negative sine squared. This right here is equal to negative sine squared. Now y'all, that's what they're gonna do. They're gonna take the identities and they're gonna flip them all around. Do y'all know how to do that? Yes or no?
No.
No? Okay, so watch this. Let me ask you this question. What is 1 minus sine squared equal to? Don't say it out loud. What is 1 minus sine squared equal to? Here's the identity right there. Yeah, so if you got 1 and you pull this sine squared over here, it becomes minus sine squared. What do you have left over here? Cosine squared. Do you see what I'm saying? What is sine squared minus 1 equal to? Sine squared minus 1, what's it going to be equal to?
Negative.
Negative cosine squared. Okay? What is 1 minus, what did I do a while ago? 1 minus sine squared? What is 1 minus cosine squared?
Sine squared.
Yeah. 1 minus cosine squared, you're left with that little sine squared over here. So you're going to have to learn how to manipulate that all around. Okay? All right, so here we go. What is sine times sine squared?
Sine cubed.
Yeah. And a negative times a positive is a negative. So there it is, all simplified out. Boom.
Are we gonna have to separate it eventually?
Separated, what are you talking about?
Like, we simplified it.
Yeah.
Oh, gosh.
No, we don't want to unsimplify things.
Oh, okay.
That's why we work on the messiest side. You're going to see in just a second. Okay, so are you ready? Here we go, example 4. What happened? Oh, I didn't like 3. So, example 4. So here we got sine theta over 1 plus cosine theta plus cosine theta over sine theta equals cosecant theta. These are the kind of problems that we're going to be doing, okay? So, it's like a game, guys. If you like puzzles, you're going to really like this. Sometimes it takes the kids 2 days before they go, I like this, Miss Davis, but they do like them, all right? So, here's the object of the game, to make one side look like the other side. Sometimes I get these comments. This is stupid. If you already know what the answer is, why aren't we doing this? Okay? Well, the object of the game is to use all your skills to make one side look like the other side. All right? So here's my first question. Which side are we working on? The left or the right?
Left.
Why?
Because it's more complicated.
That's right, it's the messiest side. Y'all, it's hard to take something that's all clean and neat and pretty and messy it up, okay? But it's easier to take something that's all messy and clean it up. We're gonna try to make this, okay? So, what's a strategy that I see that I could use?
Well, we have a one.
Yeah, I could make a cotangent right here, yes, I could, but does it accomplish anything?
No.
No. So, I could do that, but then I'd be like, well, I don't know, what am I gonna do now? Okay, so I'm gonna use the one that Judith said, and I got two fractions, so I'm gonna do what?
Combine.
I'm gonna combine them, okay? So you said to combine them, I have to have a common denominator. What is a common denominator between, y'all, this is all full of algebra, okay? What's a common denominator between 1 plus cosine and sine?
Sine.
Yeah, sine theta times 1 plus cosine theta.
How do you know that?
Because you have to have this factor and this factor. You have to have every factor that's on the bottom. And if somebody had two of them, you would have to have two of them.
So we
Okay.
can always just factor it?
All right, so now, here's what we're gonna do. We're gonna make this denominator look just like this. I'm gonna tell you this, at first I'll write this down here on the bottom, but after a while I won't because it makes my paper look so messy, okay? So, what is this denominator missing that this denominator has? What do I need to do to this guy to make him look like this?
Multiply by sine.
Okay, and whatever I do to the bottom, what?
Do the top.
What is sine times sine?
Sine squared.
Okay, you with me? All right, now look at this guy. What do I need to do to this guy to make him, y'all, this is just like the chapter 8 that y'all did in algebra, where you, it's called rational functions is what it's called. You use x's and stuff like that. We're using trig functions. What do you need to do to this denominator to make him look like this?
Multiply by plus cosine.
Okay, so 1 plus cosine theta. Do you understand why this needs parentheses but this doesn't? Does everybody understand that? Don't put this guy in parentheses and then just pop this dude out there, okay? Because what are we fixing to have to use on the top? Properties, please? Say it.
Distribute.
Distributive. Thank you. So I'm fixing to have to distribute this. So now the bottom looks just like this, so I'll multiply the top by that. What is, I'm using the distributive property. What's cosine times 1? Don't forget this plus sign right here. You see that plus sign? Don't throw him away. All right, what's cosine times cosine?
Cosine squared.
All right, you with me? Okay, so anybody, now here's some more rules, okay? I didn't really say anything to the first period class, okay? So I'll need to go back and tell them. When you work these problems, you need to kind of try to keep your equal sign in a line. We don't ever work across the page. You always work down the page, okay? Because what? Y'all, this is what I'm grading. I know what you're supposed to get. I told you what the answer was, okay? So I'm grading all of this stuff to see if you did everything that was legal. Now do you understand why I'm not grading 30 of them for you? Okay? Some people, and here's something else that'll happen. This always happens. It irritates the mess out of me. But sometimes I'll work a problem, and it'll take me like 6 steps to get the answer. And then a kid will come up there and put his paper down, and they did it in 2. And I'm like, what? Okay? So that's going to happen to you too. It's okay. We can do it in 6. All right? You just look at theirs and go, what'd you do? And then you go, oh, and you learn from it. Okay? So does anybody see anything on the top?
Yes.
What do you see?
Sine squared and cosine squared.
What is sine squared plus cosine squared?
1.
Wait, how is that 1?
Because it's a Pythagorean identity.
Oh,
That's why you need to know those. You see what I'm saying?
yes.
If you don't recognize them, you're gonna miss out. It's gonna take you a long time to work these problems. All right? Now what can I do? Sometimes it helps to cheat. Go over here and look. What am I trying to get? A cosecant. Is a sign on the bottom? Is that a good cosecant? What is cosecant in terms of sign? 1 over sign? What happens to these two things right here? What's left on the top? 1. Don't just write down sine theta, people. You got something on the top. He's on the bottom. He can't just all of a sudden sneak up on the top. So 1 over sine theta. What is 1 over sine theta?
1 over sine theta. I got you. That makes sense.
Okay? Anybody got a question?
It makes sense.
Everybody good?
Not really, but.
Dang, when I pay attention, I can really do this.
Okay, so here we go. We're gonna do, let's see, I'm gonna turn the page. We're gonna do example 5 and 6. 5 and 6 are simply skills. They're not gonna be problems like this, but they're gonna be skills that you're gonna need to work some problems. Okay? So, here we go. Example 5. I'm gonna write the word skill beside it, because all they're really trying to do is teach us a little bit of a skill. It's kind of a review, all right? So here we go. They're asking me, can I factor these?
It's raining.
Okay? So here it is. The first one they give us is secant squared theta minus 1. Now, first of all, when I see secant squared theta minus 1, what does my brain think? That's the Pythagorean theorem. Do you see what I'm saying? Okay, now tell me, this is not what we're trying to do, but I'm just trying to show you some stuff. All right, so tell me what the Pythagorean theorem is that involves a secant squared and a 1.
Tangent squared theta.
No, I want to know what the theorem.
1 plus tangent squared theta equals secant squared theta.
Okay, so 1 plus tan squared equals secant squared. So what is secant squared minus 1? Secant squared minus 1, what is it? Tan squared. All right, you see that?
Yeah.
Okay, that's pretty cool. Now, they asked me to factor it, so I'll leave this alone. That was just chasing a rabbit. So, can you factor this guy? What's this called? That's what, yes, difference of 2 perfect squares. And Belle said difference of 2 perfect squares. Sean said it factors into conjugates. Y'all remember that?
Yes.
Okay, so he factors into square root of the first, secant theta, plus square root of the second, 1, and square root of the first, secant theta, minus square root of the last.
Okay, I remember this last year, but can you go through it again? Because I don't remember how to factor it out.
I just said it. Square root of the
I know,
first,
but I was just writing it
plus square root of the second, and square root of the first, minus square root of the second. When you multiply conjugates, remember, the whole point, here's what a conjugate is. If you don't know what a conjugate is, it means it's the same exact thing, except the sign's different.
Yes.
The first term is the same, and the last term is the same, except for the sign on the last term. Okay? When you multiply conjugates, you get first times first is the first squared. Last times last is that number, and obviously it's a negative because you have unlike signs. The inners and the outers, when you foil this guy, one's positive and one's negative, so they cancel each other out. Okay? So that's why it gives you the difference of 2 perfect squares. Okay, here's another one. Are you ready?
Yes.
4 tan squared theta plus tan theta minus 3. They want me to factor it. Okay? They want me to factor it. Okay, so now look, last year, you did this last year. Y'all, this is an Algebra 1 skill, okay? Except yours looked like this. 4x squared plus x minus 3. It's the same exact thing, okay? And I'm going to say this. Don't get in the habit of rewriting it like this because these bother you. Get over it, okay? Because you don't have enough time to rewrite all that mess and then go back and write it the other way. All right, so what are the factors of 4?
2.
1 and 4 and 2 and 2, okay? What are the factors of 3? 1 and 3. What am I going to be doing with these factors? Remember this guy? He's my cheater sign. He tells you what you're doing. You're subtracting them, okay? Now look, you're going to have to multiply these. That's those inners and outers, okay? I want them to subtract to be 1. Am I going to use that 2 and 2?
No.
People, that'll give you 2 and 6. That does not subtract to be 1. okay? My brain looked at the 4 and 3 and said, whoa, you can subtract 4 and 3 and make what? 1, okay? So obviously this guy right here factors into 4 tan theta and 1 tan theta, okay? I'm using 1 and 3. Do I put the 3 right here?
No.
No, because that's gonna make 12 and 1. Does that subtract to be 1?
No.
Oh, okay? So put the 3 right here and the 1 right here, okay? I want a positive 1, so this minus sign means there'll be one's plus and one's minus. I want a positive 1, so who does the plus sign go between?
3.
He normally would go by the 3, but look, you got this 4 in here and he's playing the game. Okay? So I want a positive 1. This is going to make 4 tan theta and 3 tan theta. Who do I want to be positive and who do I want to be negative?
I want the 4 to be positive.
Yeah, I want this guy to be positive and this guy to be negative. Always check those inners and outers. Positive 4 tan theta, negative 3 tan theta.
Wait, which one are we trying to equal? We're trying to equal the first
We're not
one?
equaling anything. We're just
This is
factoring.
factoring.
Okay,
So.
we got some stuff to do tomorrow.